Okay, problem 4. Cranking out the videos today. Problem 4, and it's matching Bronsten acids with it's pairing up with its conjugate base. If you have not watched my video from instructional video 4, you must watch that because a lot of this won't make sense unless you watch that. So watch instructional video 4 and in acids bases, then you can watch this and it'll make a lot more sense. Okay, so remember from video 4, whoa, come on, what am I doing that again? Okay, that we have acids, Bronsten acids, and Bronsten, we're going to call this is my first one here. This is our Bronsten acid. Our Bronsten acids are, by definition, hydrogen plus donors, okay? And they get paired up. Remember I did my Yoda voice. And they get paired up, their pairs, with a conjugate base. Always two there are. And the conjugate base, so it's, remember I drew these to connect them. So the acid gets paired with the conjugate base, and there's an arrow between them, right? We always have this double arrow, and the base get paired with the conjugate acid. One becomes the other if you're going to the reverse. So they're just playing catch with this hydrogen ion, right? Here, you got it, boom. Hey, I got it, boom. So you're throwing that hydrogen ion back and forth. So you have your pairs here. So the acid will donate it, which means if it's donating it, it is losing an H plus ion. So which means you got to subtract an H plus ion. Well, very good. We're subtracting an H plus ion. Oops, not H minus. Subtracting H plus. So if we're subtracting an H plus, what does this become? CO3. That's a 3. CO3. Now what about the sign? We're subtracting a plus 1. Well, minus a plus 1. That's subtracting 1, Mr. Hendershot. Yes, but it's very important you remember that, because if you're going the other direction, if you subtract a negative, it could be a positive. But anyways, you're subtracting a positive. This becomes negative 2. Okay, so that's our answer. CO3 2 minus. You're just subtracting off an H plus ion every time, because they ask the same question. We're going from the Bronsten acid to the conjugate base. Now, these things put them in it's weird. They'll write this thing as CO3 2 minus. It looks weird, but you got to kind of understand that they're putting this up there. So please, I'm sorry the formatting is garbage, but if you're having trouble, post or send me an email with a picture of your work. Or if you go through this, you'll hopefully see what I mean. Okay, so we're subtracting off an H plus from this one, NO2, and it becomes a minus 1. How about this one? HS, we're only doing one at a time. It loses an H plus, a single H plus, and it's an HS single minus. This one, PO4, because we lose this hydrogen, and it's a minus 3 now. This is another one of those garbage one that will look PO4 3 minus. I'll do something wonky like that on you. Okay, this becomes OCN minus. Okay, here we go. And this becomes F minus, because we lose an H plus. PO4, oh, H, PO4, you only lose one hydrogen at a time. And then it's a 2 minus. Oh, the 4 gets all wonky in there too, but it's really a superscript. And this is CO minus. So if you want to look, my answers become this down here. And you can see the bold faces of the answers, and they're weirdly written. Those are the answers for me that I just did up there. Sorry about that. So for like that CO3, it's CO3 2 minus is what they're meaning for that one right there. And so if you have questions, you can email me. So thanks. Awesome.